from Baramati. Today we are going to learn the transcendental equations. In engineering, there are a few equations that can be solved and get the answers by regular and usual methods. The linear equations, you can write it as ax plus bx plus c is equal to 0. And also this is a linear equation. Next is that we have got the quadratic equations. You can write it in the form of x square plus bx plus c is equal to 0. So the problem with us is the changes in the quadratic equations, very small changes if you do it. It's difficult to solve the usual methods. If you do it, if x is equal to raised to 2.1 or 2.3 like this, then what will happen? It's very difficult to solve the problem. So such a type of all equations do not contain some the algebraic factors or the functions. These are called as transcendental equations, and such a types of all equations contains also the functions, or these functions are called as the trigonometric functions, the exponential function, and then the logarithmic functions. So the example may be the x square plus b into tan x is equal to c is going to be the plus c is equal to 0, going to be the trigonometric equations. This is also called as the one of the transcendental equation. Now how can we solve these transcendental equations? We got the iterative methods to solve these equations, and one of them is bisection method. And the bisection method indicates that this is a simple graph where this is f of x is equal to 0, and we have got this is the upper bound, that is b, this is the lower bound, this is b, sorry, this is upper bound, this is a, and this is the upper bound b, and we have got the alpha, which is a root. So we have got the two values a and b, that is a and b. In between these two values we will get the values, that is alpha. If the function is continuous, then we can find the values of alpha, how it comes out to be. We take the starting values of, or the values of equation of f of x. These starting values can be obtained by some techniques. Initial values can be the upper bound and then lower bound, and then iteratively we approach towards the solutions till we get the f of x is equal to 0. There are some common methods available, and this is one of the common methods, which is called as the bisection method. The theorem says that the f of x is continuous. This is f of x is continuous in the interval a and b. Then one is negative and other is positive. Then the solution of f of x must be in between these two values. This means that there must be at least one root lies between a and b. So we will see the example, and the example is 2x plus 1 square is equal to 4 cos of pi x, and with the given interval, that is, you can say a is equal to 1 by 4 and b is equal to 1 by 3. After putting the values of a and b, we will get the values f of a, which is you will find less than 0, and f of b, which is find greater than 0. After the calculations, if you see that the values of f of a is less than 0 and f of b is greater than 0, So the values are opposite to each other. Hence the root lies between these two values, that is a and b. So again we have to take the main point of this now, a and b. So you have to take c1 is equal to a plus b upon 2, that is nothing but 1 by 4 plus 1 by 3 divided by 2. And then we will find that the values are 7 by 12 into 2, that is 7 by 6, and going to be if you take this c1 value as 7 by 6, then we can see now this is, and this c1, if you do it with functions which is the continuous functions which we have taken, that is 2x square plus 2x plus 1 square is equal to 4 cos by x, then we will get the value of f of c1 is in between the 0.297. So again you can see now f of c1 is greater than 0. So this is f of c1 is greater than 0. So again the root lies between. Now the root, this is alpha, this was a, this was a b. Now the root lies between 1 by 4 and then this is 0.2917 and 1 by 3. So do these steps for at least 4 or 5 times, or 6 or 7 times, you may be as you require, so that till you get the answer to the real root.